The shortest distance between 2 points is a straight line. Sounds trivial? It is in fact a consequence of the triangle inequality. The sum of two sides of a triangle is always longer than the third side. Well, this may seem trivial to do, but to actually prove this still requires some work. And though this triangle inequality may look pretty obvious, it is still used pretty often in more advanced computations, where you have to estimate certain quantities instead of compute them. So let us take into the formulation and the proof of the triangle inequality in this video. So here we have the vectors u and v, and again another v, another u. So we can form the red vector, which is the vector u plus v. And what does the triangle inequality tell us? Well, going from here to there, then the red line is shorter than the white and the yellow line. That's all. So the length of u plus v over here smaller or equal than the length of u plus the length of v. Going straight is faster than going like this and like that. But how are we going to prove this? Well, we use the same trick as for we use for Cauchy-Schwarz. So again, those quantities here are positive, so we can use that if a is smaller or equal than b, you can also show that a squared smaller or equal than b squared instead, since we have positive quantities. So if we want to show that length of u plus v is smaller or equal than length of u plus v, we can show instead that the length of u plus v squared is smaller or equal than, mind the brackets, u plus v brackets and length squared. And then we do again the same trick. We take this u plus v, length of u plus v squared to the right hand side, and we show that the length of u plus length of v squared minus length of u plus v squared is positive. So it's a similar trick like we did in Cauchy-Schwarz. Well, we have been shifting around only, so how are we going to prove this for any vectors u and v in Rn? So what we do, first we compute length of u plus length of v squared. Work out the brackets, length of u squared plus length of v squared plus 2 times the double product plus 2 times length of u times length of v. Then we look at length of u plus v squared. So length of u plus v squared. That is the inner product between u plus v and u plus v. So inner product u plus v and u plus v. Work out again the brackets, u inner product u inner product v, v inner product u, v inner product v. So what do we get? Length of u squared, length of v squared, plus 2 times u inner product v. And then we have to show that the difference of those two terms is in fact positive. So what do we get? We see that the u squareds over here cancel out. We see that the v squared over there cancel out. And we are left with the 2 times length of u, length of v, minus 2 times the inner product of u inner product v. And we have to show that this quantity is positive, so we have to show this quantity over here is positive. But hey, now we can use Cauchy-Schwarz, which we have just proven. We have shown that u inner length of u times length of v is bigger or equal than the inner product of u and v. Dus that means that this part is bigger than that part. So the difference between the two will always be positive. That means that this part over here is positive, and that means that going all the way back, that the difference over here is positive, like that, which was equivalent to showing that this one is smaller than the sum of those two. So now you know for once and always, going from one point to the other, another point in a straight line, is always faster than taking a detour. Some mathematics which you can use in practice.